Welcome to my video. In this session, I will explain about my paper in Linear Algebra and Geometry course, EF 2123, about application of fractal geometry in generating variations of this Kalimantan Batik motif based on Julia's set. So, first of all, I will introduce what my paper is about. Indonesia is well known for its diverse backgrounds, culture, and heritage. One of it is Batik, officially recognized as UNESCO Intangible Cultural Heritage of Humanity in October 2nd, 2009. So, later then, Indonesia features numerous batik motifs, characteristic of various regions, including East Kalimantan, representing the province's rich cultural identity. So, East Kalimantan is a province in Indonesia known for its rich natural resource and cultural diversity. Various home to various ethnicities such as Dayak and Kutai, whose tradition and aesthetic expression have significantly influenced local craftsmanship, particularly in Batik. So East Kalimantan is my hometown. So because that I choose East Kalimantan for my object in this paper. Now the creation of Batik motif has advanced significantly from handcrafting methods to explain applying mathematical principles, particularly in fractal geometry. So, fractal geometry is a branch of mathematics that studies the properties and behaviors of various vectors. Unlike the most conventional mathematical forms, fractals have generally irregular shapes that do not follow linearity. Therefore, this paper refers how Python programming and photo editor generate creative variations of this Kalimantan Batik motif. This paper introduced Julia set as the fractal geometry implementation for developing the Batik motif. So, after this is initialization section that I initialize the color palettes for the visualization. So just ignore this and then import the necessary libraries. So I've used NumPy, Pandas, and Matplotlib. So NumPy for the calculation, array calculation, and matrix calculation. Matplotlib is for the visualization. Now, before we dive into the Julia set, uh, I hope uh, the audience here is already known about complex number. So let me skip a little bit. So the complex number is basically from a real number and imaginary number. So a plus, so this real of c and imaginary of c that defined in a plus bi. So what the correlation complex numbers in Julia said that complex numbers is can be used for creating the Julia set with the iteration about the many times so that it creates a random pattern but beautiful. So this for the class definition. In here for the initialization, the class is taking input complex number and then the number of iteration and the dimension of the Julia set that we wanted. So the higher the dimension, the higher the quality, the higher the iteration, the complex the pattern is gonna be generated from this class. Then for compute, we use the NumPy to initialize the range and the grid, and then combine the real and imaginary parts to a single complex grid. After that, we create a max. So the max is for use in the visualization because the Julia set is typically have two types for the visualization, that is the escaping point and then the not escaping point. So I will talk about it later. This is the iterative Julia set algorithm. So for we iterate to the max iteration, uh, this gonna be z n plus 1 equals to z square plus the c itself. So until we check in the if is escape, we will track it and then make it never escape. The never escape is to handle the connected Julia set. So this is the type for the visualization generator. I will talk it later. And then if not have any max, that will break. So normalize the escape times for x, y, and f, and then the max here. Now to the visualization, we are taking a axis from a figure and then the number of gradients and then the palette color that we wanted that I have defined in the initialization before. So the chosen palette is selected from the palette and then making the C map as linear segmented color map from the with the number of gradients here, and then we plot the axis. Then if we want to save it to the database, and we just use the definition of save, is literally the same, but it includes this code that save and then appending to the database. Now this get title just for the labeling, so just can be ignored. Now we dive into the types of Julia set. So the first combination is complex number with only real values. C constant with only real values, so that the real is not 0 but the imaginary part is 0. So I have chosen the black, black, gold, black color for each complex number I have selected. So it's 0.3, negative 0.6, negative 1.2, and then negative 1.5. So if I run, this took a long of time because the iteration, so I will skip the running. But here's the output. So here for the C equals 0.3, negative 0.6, negative 1.2, and then negative 1.5. So what I have discussed before is connected and not connected. So this is the example of connected. So it's just solid color with inside it colored with a single palette, and then this not connected Julia set. Then we use the gradients bubble around it to visualize the pattern with the color wheels. And then the second combination is with only imaginary values, so 0.63, 0.7, negative 0.8, negative 0.9. So why what the reason I choose these complex numbers is already taught in the paper, but so this range is creates good Julia sets that will be used in our variation of the Batik motifs. So if you like look in here, it creates good fractals of Julia sets that possibly have potential for our Batik motif. And then the third combination is with the both real and imaginary values is not 0. So 1.37, and then the imaginary one 0.1, and then so on. Then with the chosen palettes. So here therefore the third combination. And then we dive into the next section is combining elements. So first we need to fit the image so we can combine it at the same size. Just use this algorithm. I think I don't need to explain more of this algorithm because it's not related to our main topic. So here I chosen Julia set number 1 with the hue Taliesin. So for context, this is the Kalimantan Batik motif I've choose for this generation of variations. So first is hue Taliesin, and then kuntul perak, rutun penyu, tengkawang apik, and then second tengkawang apik. So there's 5 motifs that will be implemented here. So the combinations will open the foreground and background. We have chosen which foreground and backgrounds, and then we combine with this pillow library, F, and then this is the result of the combinations. Looks good. And then for the complex, I mean the literal complex pattern that cannot be used just for a simple combination, I've decided to manual combine it with Figma photo editor. So the the main point is I cannot combine it automatically with Python codes to create this pattern. So there is the little image. If you can see there, the like a code in here. This Julia said that can yeah kinda not visible. So here the manual and coded combinations. After that, we dive to generating the Batik motif variation, which our main topic in here. So we defining the generation, we defining the generator with loading the image, and then this is the main point of it. So we're making a grid with the pattern that looks like this. If I create in here, maybe. So the pattern is 1 2 3 4, and then 1 2 3 4, and then 1 2 1 2 3 4 3 4, and so on. So the pattern is gonna be look like this, and then this the implementation of it, and then we use the flip so it not just repetitive motif. So we visualize the variation. For the first variation, I use the motif Tengkawang Empik in here, and then the Julia set number 2, and then combination number 5, I think is manual combination, and then the first combination is coded combination, and the result just look like so we do right. And then the second variation, I chosen the combination number 6, Julia set number 3 with the yellow color, combination number 3, and combination number 2. So this number 6, Julia set number 3, our little turtle in here, and then the kind of seaweed thingy in here. And then for the third variation, I'm choosing the Tengkawang Empik number 2, combination number 4, combination number 7, combination number 6, number 8. Yeah. So I think this not gonna be so long to run. So for the sake of the video in here, hopefully it won't run like right. So it's working. And then for the second variation, and then for the third variation. Also, it's gonna be our save in here, the Julia sets, and then the combinations is always be saved. And so don't worry to check the transparent format for the image that you can use for your further implementation of this paper. So the third image is the Kuntul Perak is standing on the cloud, and then with this black is like Japanese art in here. But in the second variation, just kind of sea theme like that, and the turtle is just diving in the sea with the seaweed, and then here just typical of Kalimantan Batik type motif. And then for the closing for together, if we run, it's also second variation. So here the for combine it in a single plot. So here the first variation, second variation, and third variation. So if you interested more to further implement this paper, so you can visit my repository in here, Algio Julia set. So it's already completed. So with the archive, combination, Julia set, motif, and variations, I will upload the documents too after this. So yeah, I will update the README too. So thank you for listening to my and watching until this minute. So hopefully you have better understanding about fractal geometry, Julia said, and our beautiful art in as heritage Indonesia heritage is batik, especially for my hometown is Kalimantan batik. So thank you very much for the attention. See you later.